Happy New Year! Welcome to our first lesson in the second quarter of the Research 4 subject. This lesson will introduce us to the deeper understanding of the scientific method and the different approaches used in research. At the end of this lesson, you are expected to describe the reasoning involved in the scientific method and the different approaches to research. I easily recognize that research is a relatively unfamiliar discipline for many of you. Our first goals, then, are to help you acquire a general understanding of research processes and to help you develop the perspective of a researcher. We begin by looking into the scientific method. What is knowledge? And how do we come to know something? Experience is certainly one of the fundamental ways we come to know about and understand our world. For example, a child who touches something hot learns that high heat hurts. We know other things because a trusted authority, such as a parent or a teacher, told us about them. Most likely, much of your knowledge of current world events comes second-hand, from things you have read or heard from a source you trust. Another way we come to know something is through thinking, through reasoning. Reasoning refers to the process of using logical thought to reach a conclusion. We can reason by either inductively or deductively. Inductive reasoning involves developing generalizations, based on observation of a limited number of related events or experiences. Deductive reasoning, on the other hand, involves essentially the reverse process, arriving at specific conclusions based on general principles, observations, or experiences. Let us now explore more about inductive reasoning. Consider the following pieces of evidence on ancient predators. Every known predator has eyes to the front of its skull, and not to the side. And, carnivores lack flat molar teeth. Now, you happened to discover a fossil of a mysterious animal, that has eyes to the front, and lacks flat molar teeth. What would be your conclusion about this fossil? Try to answer this question by selecting the appropriate option on the screen. Following the inductive reasoning, you would likely to answer that the new fossil is likely that of a carnivorous predator. This is how inductive reasoning works, by developing generalizations, based on observation of a limited number of related events or experiences. Let us now explore more about deductive reasoning. Consider the following pieces of evidence about noble gases. All noble gases are stable. And, neon is a noble gas. Now, what will be your conclusion about the stability of neon gas? Try to answer this question by selecting the appropriate option on the screen. Following the deductive reasoning, you would likely to answer that the neon gas is stable. This is how deductive reasoning works, by drawing a conclusion from available information. Deductive reasoning also allows you to apply what you have learned. Although people commonly use experience, authority, inductive reasoning, and deductive reasoning to learn new things and draw new conclusions from that knowledge, each of these approaches to understanding has limitations when used in isolation. With inductive reasoning, generalizing from a small sample, especially one that is atypical, can lead to errors. Moreover, deductive reasoning, too, is limited by the evidence in the original observations. When we rely exclusively on these common approaches to knowing, the resulting knowledge is susceptible to error, and may be of limited value to understanding the world beyond our immediate experience. However, experience, authority, and inductive and deductive reasoning are very effective when used together as integral components of the scientific method. The application of the scientific method is standard in research. It is more efficient and more reliable than relying solely on experience, authority, inductive reasoning, and deductive reasoning as sources of knowledge. The steps in the scientific method, which you have learned in the previous quarter, guide researchers in planning, conducting, and interpreting research studies. However, it is important to recognize some limitations of the scientific method. First, the scientific method cannot answer all questions. For example, applying the scientific method will not resolve the question, should we legalize euthanasia? The answers to questions like this one are influenced by personal philosophy, values, and ethics. Second, application of the scientific method can never capture the full richness of the individuals and the environments under study. Although some applications of the method lead to deeper understanding of the research context than others, no application and in fact no research approach provides full comprehension of a site and its inhabitants. No matter how many variables one studies or how long one is immersed in a research context, other variables and aspects of context will remain unexamined. Thus, the scientific method and, indeed, all types of inquiry give us a simplified version of reality. Third, our measuring instruments always have some degree of error. For example, even if we use a very precisely calibrated beakers to measure liquids, we cannot achieve a 100% accuracy. Sometimes researchers deal with human beings, live animals, and microorganisms. They must consider a number of ethical issues and responsibilities in conducting these studies. Historically, researchers used varied approaches that involved the use of the scientific method. However, over the last 3 decades, researchers have adopted diverse philosophies toward their research. Now, there are certain philosophical assumptions that underpin a researcher's decision to conduct research. These philosophical assumptions address issues related to the nature of reality, known as ontology, how researchers know what they know, known as epistemology, and the methods used to study a particular phenomenon, known as methodology. Researchers have also followed well-defined, widely accepted procedures for stating research topics, carrying out the research process, analyzing the resulting data, and verifying the quality of the study and its conclusions. Often, these research procedures are based on what has come to be known as a quantitative approach to conducting and obtaining scientific understandings. Quantitative research approaches the collection and analysis of numerical data to describe, explain, predict, or control phenomena of interest. However, a quantitative research approach entails more than just the use of numerical data. At the outset of a study, quantitative researchers state the hypotheses to be examined, and specify the research procedures that will be used to carry out the study. They also maintain control over factors that may interfere with the data collection and identify a considerable sample of entities or subjects, large enough to provide statistically meaningful data. In the last 20 to 30 years, however, non-quantitative approaches to research have emerged. Qualitative research now has as many research practitioners as quantitative research. Qualitative research is the collection, analysis, and interpretation of comprehensive narrative and visual, for example, non-numerical data, to gain insights into a particular study of interest. Qualitative research are based on different beliefs and designed for different purposes than quantitative research approach. For example, qualitative researchers do not necessarily accept the view of a stable, coherent, and uniform world. Qualitative research problems and methods tend to evolve as understanding of the research context and participants deepens. As a result, qualitative researchers often avoid stating hypotheses before data are collected, and they may examine a particular phenomenon without a guiding statement about what may or may not be true about that phenomenon or its context. However, qualitative researchers do not enter a research setting without any idea of what they intend to study. Additionally, in qualitative research, variables are neither controlled nor manipulated by the researcher. It is good to note, however, that qualitative research methods have been mostly used in sociology, anthropology, political science, psychology, social work, and educational research. There are several research approaches that any researcher may use to proceed with his or her investigation. These approaches are classified based on how each approach describe current conditions, investigate relations, and study cause and effect phenomena. Survey research determines and reports the way things are. It involves collecting numerical data to test hypotheses, or answer questions about the current status of the subject of study. Below is an example of a scientific research using surveys as approach. Another research approach is correlational research. This involves collecting data to determine whether, and to what degree a relation exists between two or more quantifiable variables. A variable is a placeholder that can assume any one of a range of values. For example, volume, height, and temperature are variables. At a minimum, correlation research requires information about at least two variables obtained from the entities being studied. The purpose of a correlational study may be to establish relations or use existing relations to make predictions. Correlation refers to a quantitative measure of the degree of correspondence. The degree to which two variables are related is expressed as a correlation coefficient, which is a number between -1 and +1. Two variables that are not related have a correlation coefficient near 0. While two variables that are highly correlated will have a correlation coefficient near +1, or -1. Many scientific research, usually, use this type of approach. Below is an example of a correlational research. Causal comparative research attempts to determine the cause, or reason, for existing differences in terms of characteristics being studied. The cause is either a behavior, or characteristic, believed to influence or cause some other behavior, or characteristic. The changes or differences in behavior, or characteristic that occurs as a result, is known as the dependent variable. Put simply, causal comparative research attempts to establish cause and effect relations among groups or entities being studied. Here is an example of a causal comparative study. In experimental research, at least one independent variable is manipulated, other relevant variables are controlled, and the effect on one or more dependent variables is observed. True experimental research provides the strongest results of any of the quantitative research approaches, because it provides clear evidence for linking variables. As a result, it also offers generalizability, or applicability of findings to settings and contexts different from the one in which they were obtained. Most of the research in science fall under this approach. Unlike causal comparative researchers conducting an experimental study can control an independent variable. They can select the participants for the study, divide the participants into two or more groups that have similar characteristics at the start of the research experiment, and then apply different treatments to the selected groups. They can also control the conditions in the research setting, such as when the treatments will be applied, by whom, for how long, and under what circumstances. Finally, the researchers can select tests or measurements to collect data about any changes in the research groups. Now, let us check what you have learned so far. Try to answer this short test.